I'm Algebra Annie, and I am here to help you be successful in your algebra class. Mistakes are proof that you are trying. Unknown. Our learning target today is I can graph and solve systems of linear inequalities in two variables.
Now we are solving systems of linear inequalities. And the first thing that we always learn is we always learn how to tell whether an ordered pair, this is our ordered pair, is he actually a solution or is he actually the answer to our given system? This is our given system. So this is basically just them telling us to check the answer that they gave us. Is this answer that they gave us the actual answer? This is the process that you would use to check your answer each and every time you think you found an answer when we go on to the next method. So I say I have two equations in my system. I need to test equation number 1 and I need to test equation number 2 to make sure that this ordered pair, this xy coordinate point, works for both. It has to work for both. So this is an xy coordinate point. Our first equation is y is less than negative x plus 4. Equation number 2 is y is less than or equal to x plus 1. So equation number 1, I need my y. My y was 1 is less than. I need the negative of whatever x is. X is 2, and I'm supposed to add 4. You're trying to prove, which means the left needs to be worked down till it's one number, and the right needs to be worked all the way down till it's one number. So 1 is already a 1, less than. Negative 2 plus 4 is a positive 2. Now you need to test to see if this statement is true. Is 1 smaller than 2? Yes, 1 is smaller than 2. This is a true statement, so it works for number 1. So let's check equation number 2. I need my y. My y was 1, less than or equal to. I need my x, which is 2, plus 1. The left side was already 1, less than or equal to. 2 plus 1 is 3. Is 1 smaller than or equal to 3? Yeah, 1 is smaller than 3. So this statement is also true, which means it works for equation number 2. If it works for equation number 1 and for equation number 2, then it works for this entire system. If it works for the entire system, then you say yes. The coordinate point 2, 1 is a solution. And you have just checked your work. So let's go ahead and practice it for another one. Tell whether the ordered pair, this is our ordered pair. An ordered pair is an xy coordinate point. Tell whether this xy coordinate point is a solution, that means check to see if he is actually an answer, to the given system. This is our given system. There are two equations, which means I need to test to make sure that the coordinate point they gave me works for both equations. Equation number 1 and equation number 2. So in equation number 1, this is an xy coordinate point. My y was 0, so there's 0, is greater than or equal to 2 times my x, which was a 2. The left side is already a 0, greater than or equal to. 2 times 2 is 4. Is 0 bigger or equal to 4? No, 0 is not bigger than 4, and 0 is not equal to 4. This is not true. So since this one is not true, we automatically know that no, this point is not a solution. Remember, it had to work for both equations. If it automatically does not work for the first equation, it can't work for the system at all. Now let's pretend it did work for equation number 1. You always still need to check equation number 2. So y was 0 less than, x was 2 plus 1. 0 is on the left, less than, 2 plus 1 is 3. Is 0 smaller than 3? 0 is smaller than 3. This statement is true, but it honestly still doesn't matter because number 1 did not work. So if you check them both and one of them does not work, no, it cannot be a solution. Now we're actually being asked to find the solution. We don't know what it is. We need to find it. And you'll be happy to know that graphing is the only method that we actually use when solving for linear inequalities. So we're only going to graph. It tells us to graph these two linear inequalities. And then when we're done, we need to give two ordered pairs that are solutions and then two ordered pairs that are not solutions. So let's go ahead and take this. There are two equations, which means I need to split this up into two areas. I want to work through equation number 1, and I need to work through equation number 2. So equation number 1, 8x plus 4y is less than or equal to 12. Equation number 2, y is greater than 1/2 x minus 2. So that they told me that I needed to graph it. So step number 1 is to make sure that your equation is solved for y. So we're going to go ahead and we're going to solve our inequality for y. So our inequality was 8x plus 4y is less than or equal to 12. I need to solve for y, which means I need to get y by itself. So first this 8x needs to go away. So I'm going to subtract 8x from both sides. I have 4y is less than or equal to 12 minus 8x. I need y by itself, so I'm going to divide everything by 4. Now stop and wait. We divided. The minute you divide, you need to look at what did you divide by. It's a positive. Since this is a positive, we do not reverse. So my symbol stays looking the same. 4 divided by 4 is 1, so I'm left with just 1y. 12 divided by 4 is 3. A negative divided by a positive is a negative. 8 divided by 4 is 2, and that was the number stuck to x. Now, if you want it to be in proper slope-intercept form, this negative 2x part should have been written first. So the negative 2x part should have been written first, and that positive 3 should have been written second. This is now in proper slope-intercept form. Well, now we just need to go ahead and graph it. So step 2 is to graph. If we're going to graph this, we need to find out what our y-intercept is, and we need to figure out what our slope is. My y-intercept is the lonely number without any letter. It's the b. My y-intercept is a positive 3. My slope is the number stuck to x. My slope is a negative 2. Now remembering slope needs to be a fraction, so if you put it over 1, it's automatically a fraction. After we graph it, we're supposed to figure out how it is supposed to be connected. So remembering from our previous lesson, the connection is all about the symbol. This is my symbol. It is less than and equal to. Remembering from our previous lesson, if there's an equal to sign on it, that meant that the entire line had to be equal to. So it was a solid colored in line. And then step 4 is to try and figure out how do we actually shade our graph. Remembering from our previous lesson, the symbol is all about the shading. It's less than. Less than meant that we had to shade below our line. So we're going to go ahead and graph this line, make sure it's a solid line, and we're going to shade below. So let me get my graph paper. Okay, so my y-intercept was 3. So here's my y-intercept of 3. I'm supposed to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Do it a couple of times so I make sure that I always do my line correctly. Now I'm connecting this with a solid line because my symbol told me it was equal to. So here is me connecting it with a solid line. I need arrows on both ends. And down here, I'm just going to write that this was equation number 1. Now I need to shade, and I'm supposed to shade below. And so that I can remember equation number 1 was the equation shaded with the green, I'm going to put a little green dot right next to equation number 1. And it was below. So slope dude was standing right here. So if I could draw slope dude on my line, here's slope dude. And if he was traveling along his mountain, I'm supposed to shade wherever below his feet are. Where's below his feet? Below his feet would have always been this way. So any point on this side of the line would have been an answer to that inequality. But we're looking for the system, which means equation number 2 needs to be graphed right on top of the same exact graph paper. So now let's go ahead and take a look at equation number 2. So here's equation number 2. Step 1. Step 1 is to solve the inequality for y. It needs to be a y equals or a y inequality statement for us to be able to pull apart the y-intercept and the slope. So this is our equation. Y is already solved for. Y is already by itself. So step 1 is already done. So step 2 is to figure out the necessary information that we would need to be able to graph it, which would have been the y-intercept and the slope. My y-intercept is the lonely number without any letter. My y-intercept is a negative 2. My slope is the number stuck to x, so my slope is a positive 1/2. After we found the proper information to graph, we need to figure out how would we have connected our line. So to figure out how to connect, we look at the symbol. The symbol, it has no equal sign. If there's no equal sign, that meant the line is not equal to an answer, which meant it had to have been a dashed line. And step number 4, we need to figure out how do we actually shade once we graph our line. So the symbol is what tells us how to shade. This is greater than. If you are greater than, you are always going to be shading above slope dude. So let's go ahead and take out that graph paper that we did before. So here's our graph paper. Looking at this equation, I am supposed to graph the y-intercept of -2. So here is my y-intercept of -2. My slope is up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. I'm supposed to connect it with a dashed line because the line is not equal to an answer at all. So here is me connecting with my dashed line. There's my dashed line. You need arrows on both ends. Now if slope dude, pretend nothing else is on here. This line right here is line number 2. And slope dude would have started on the furthest left part of that line. So there's slope dude starting on the furthest left part of the line. Now I'm doing this one in a different color. I'm going to do this one in red. And so that I know line number 2 is the one shaded in red, I'm going to put a little red dot next to number 2. Now it said the shading had to be above. So here is slope dude on line number 2. If he was traveling along his line, like we do from left to right, where is always above slope dude's head? Above slope dude's head would have always been this direction. So if we were only looking at line number 2, anything up in this direction would have been a possible answer. But we're not looking at just line number 2. We're looking at the system. Now the solution to the system is where both shadings will always be. I can see that I have both red and green shadings all over here. So any point that is in both the red and the green at the same exact time is going to be an answer. So everything up in this area is going to be our answer. Now looking back over here, we're not done. I'm going to separate the spot down here. We're supposed to figure out 2 solutions, and we're supposed to figure out 2 non-solutions. So 2 solutions and 2 non-solutions. Any solution that is in both the red and the green is an answer to the entire system of inequalities. So you can pick any point over here. I see that the point 0, 0 is in both the red and the green. So the point 0, 0 is a solution. I see that the point -6, 0 is a solution because he is in both the red and the green at the same exact time. I can see that the point 0, 4 is a solution because he is in both the red and the green at the same exact time. Now I need 2 non-solutions. So I'm looking. The dashed line means it's not an answer, which means this coordinate point, 0, -2, is not an answer because he is not shaded red, because he's on the dashed line. 0, -2 is not an answer. So what else is not an answer? Going over, anything over in the white is not going to be an answer because it was never shaded. So 8, 0 is not an answer. Looking over, anything that's purely only red is not an answer because it had to be both. So 6, 3 is not an answer. Anything shaded in purely green is not going to be an answer. So 0, -6 is not an answer because it was purely green. We only needed 2, but I provided a few so we could see what could be answers and what could not be answers. So what is your answer to this final question? It is the graphed system of inequalities because we can see anything over here is your answer. 2 examples of solutions and 2 examples of non-solutions. You need all 3 parts to have a final completed answer. So let's go ahead and graph another one. So they want us to go ahead and graph this linear inequality and describe what our solutions would be. Since I know that I have to graph 2 lines, I'm going to split my paper into the 2 sections so I can concentrate on line number 1 and I can concentrate on line number 2. So the first line is the inequality y is less than 2x minus 3. The second line is the inequality y is greater than 2x plus 2. So focusing just on the first line. Step 1 is to solve for y. So I have y is less than 2x minus 3. Turns out that y is already solved for, so solve for step 1 is done. So step number 2, we need to figure out all the important details that we would need so that we could actually graph it, which means we need to figure out what the y-intercept is, and we need to figure out what our slope is. My y-intercept is the b. It's the lonely number without any letter. -3 is my b, my lonely number without any letter. My slope is the number stuck to x. My slope is 2. But remembering slope has to be a fraction. So I put it over 1, and now I have my slope. Step number 3 is how do we actually connect this when we graph it? To figure out how to connect, you look at the symbol. This is the symbol that we are graphing. This is not equal to. There is no equal to sign. If there's no equal to sign, then it's going to be a dashed line. And step number 4 is how do we actually shade it? And for figuring out how to shade, we look at the symbol again. My symbol is less than. If it's less than, that you are always going to be shading below. So each time that we were looking at the symbol, this was the symbol that we were focusing on, the one that was in the solved for y equation. Now let's go ahead and graph it. So here is my graph paper. My y-intercept is -3. Here's -3. My slope is up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. When I connect these, I'm supposed to connect them with a dashed line. So here's me connecting with my dashed line. Now you need to make sure that you have arrows on both ends. And I like to label the line. So this is line number 1. And if slope dude is on this line, slope dude always starts on the furthest left part of the line. I'm going to shade this one green. And so I can keep things distinct, I'm going to put a green dot next to number 1. Now I'm supposed to shade below. So slope dude is traveling along the line. Everything below his feet, which is over here, is going to be an answer. So everything over here is going to be an answer. Now the line was dashed, which means nothing on the line can be an answer. That's why it was dashed. It's not equal to. The line's not an answer. So now we're going to put this aside and save it for a second because now we have to figure out what line number 2 looks like. So line number 2, step 1. Step 1, I need to solve for the y. So the inequality was y is greater than 2x plus 2. He's already solved for y. So this is the equation we're going to be graphing. Since that's the equation we're going to be graphing, that's the symbol we're going to refer to when we figure out how to connect and how to shade. So step number 2, what are all these special important details we need to know so that we can actually graph this line? Which means I need to know my y-intercept and I need to know my slope. My y-intercept is the b. It's the lonely number without any letter, the positive 2. My slope is the number stuck to x. My slope is going to be 2, and you need to make it a fraction, which means I need to put it over 1. Step 3, we need to figure out how do we actually connect this. To figure out how to connect, you look at the symbol in the step 1 equation. So it was a greater than symbol. There is no equal to there, which means the line is not going to be a possible answer, which means we have to connect it with the dashed line. And step 4, how do we actually shade this? To figure out how to shade, you look at the symbol from step 1. This was the symbol from step 1. It's above. It's greater than. So anytime you shade greater than, you're going to be shading above. So let's go ahead and get out that graph paper. So here is the graph paper that we used for line number 1. We have to graph line number 2 right on top. So my y-intercept is 2. Here's 2. My slope is up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. When I connect these, I'm supposed to connect them with a dashed line. So let's go ahead and connect with a dashed line. Don't forget to put arrows on the end, and then I like to label my line. So this was line number 2. And now I got to figure out how to shade. Slope dude always starts on the furthest left. And in shading, I want to keep my things separate. I'm going to shade in red. So I'm going to put a little red dot right next to number 2. I'm supposed to shade above. So as slope dude is traveling along his line, anything above him, which would have been everything on this side, is going to be an answer. So now we got to look at our graph. They told us to describe our solution. So describing our solution, it's wherever the two colors meet. So splitting down here, I'm supposed to now describe my solution. Your answer is wherever the two colors meet. So I'm looking, where are both of my colors shaded? There's no way where both of my colors shaded. I have green on the right and I have red on the left. They never shade together, which means we will not have a solution. So this system has no solution. And that's your answer, you're done. So our next problem, again, they want us to graph this system and then describe where our answer is. Since we only have 2 equations that we're graphing, I'm going to split my paper into the 2 sections, so that I know I am graphing equation number 1, and I need to graph equation number 2. Step number 1. Step number 1 is to solve for y. If it's not y by itself, it's not in proper y equals mx plus b form, slope-intercept form, which means we can't graph it. So the equation was y is greater than x minus 3. Well, y is already by itself. So it's already in slope-intercept form. So we're done with step 1, which means now we need to move on to step 2. Step 2 is figuring out all the important information that we need so that we can actually graph it, which means I need to know what my y-intercept is, and I need to know what my slope is. My y-intercept is the lonely number without any letter. -3 is my lonely number without any letter, my b. Slope is the number in front of x. X exists, so there's got to be a number in front of it. If there isn't one, it's a 1. And slope has to be a fraction, so put it over 1. Step number 3, when we actually graph it, we need to know how to connect it. So we look at the symbol from step number 1. That's the symbol that we are going to be using. There is no equal sign. If there's no equal sign, then the line itself is not an answer, which means it needs to be a dashed line. And step number 4 is figuring out how to actually shade it. So to figure out how to shade, we look at the symbol from step 1. There's my symbol. It's greater than, which means I need to be shading above my line. So let's go ahead and get our graph paper. Okay, my y-intercept was -3. Here's -3. I'm supposed to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Keep going until I have quite a few. Now when connecting them, step 3 says I need to make sure that I connect it with the dashed dotted line. So here is my dashed line. You need to have arrows on both ends, and I like to label my line. This was line number 1. Now I need to shade it. Now so that I can make sure that my colors are separated, I'm going to go ahead and color this one in green. I'm going to put a little green dot next to line number 1. It says I'm supposed to shade above. Slope Dude always starts in the furthest left, and as he's traveling along my mountain, I'm supposed to shade above his head. So he's traveling along. Where is above Slope Dude? Above Slope Dude is always over here. So anything over in this area is going to be an answer for line number 1. So now let's move on and figure out line number 2. So step 1, we need to solve for y. So the equation we were given was y is less than or equal to x plus 1. We're supposed to solve for y. Well, y is already by itself, so step 1's already done. So now we got to move on to step 2. We need to figure out all the important information that's necessary so that we can actually graph it, which means we need our y-intercept and we need our slope. The y-intercept is a lonely number without any letter. My y-intercept is a +1. My slope is the number in front of x. My slope is 1. Slope has to be a fraction, so you put it over 1. Step 3 is telling us how do we connect it when we actually go ahead and graph. So to do step number 3, we have to look at the symbol left behind in step 1. This is a less than or equal to. Equal to means we need to make sure that we connect with an equal solid line. So when graphing, we need to connect with a solid line. And then step number 4, we got to figure out how to actually shade it. We got to look at the symbol from step number 1. This is a less than symbol. If you are shading less than, then you are always going to be shading below Slope Dude's feet. So my y-intercept was 1. There's my y-intercept of 1. I'm supposed to go up 1 over 1, up 1 over 1, up 1 over 1. There's my few points. When I'm connecting it, it says that I need to connect it with a solid line. So here's me connecting with my solid line. You have arrows on both ends, and then I like to label my lines. So this is line number 2. And Slope Dude always starts on the furthest left. So here's Slope Dude. And I want to color this one in red. So here's a red dot next to line number 2. So I remember he was the red one. I'm supposed to shade below. So as Slope Dude is traveling along his mountain, I'm supposed to shade below his feet. Now I'm looking at line number 2. Below his feet would have always been this direction. So anything this way is going to be an answer for line number 2. So our final answer is describe the solution. So looking at this, I want where green and red are both shaded. So where are green and red both shaded? I notice it's only between the two lines. And these lines look parallel. What do we know about parallel lines? We know parallel lines have the same slope. Line number 1 had a slope of 1. Line number 2 had a slope of 1. These are parallel lines. So they're never going to intersect somewhere, which means their shading will always be between the two parallel lines. So my solutions are between the two parallel lines. And you're done. Our last problem. I need to graph the solutions. I need to graph these inequalities and then describe where their solutions are. So here's me splitting my paper. So I have space for line number 1 and I have space for line number 2. Line number 1 was y is less than or equal to negative 3x minus 2. Line number 2 was y is less than or equal to a negative 3x plus 4. Step number 1. I'm supposed to solve for y. So I was first originally given this equation and I need to solve for y so it's in slope-intercept form. Y is already by itself. So step 1's actually already done. So step 2, what is all the important information so I can graph it? Which meant I needed to know what my y-intercept was and I need to know what my slope is. My y-intercept's a lonely number without any letter. My y-intercept is a negative 2. My slope is the number in front of x. My slope is a negative 3. Slope needs to be a fraction, so you need to put it over 1. Now when actually graphing it, step 3 tells us how we should connect. So to figure out how to connect, I got to go up and look at the symbol from step 1. This is my symbol from step 1. There's an equal sign in there, which meant my line needs to be solid because my line is equal to an answer. And then step number 4 tells us how we should shade our inequality to find our answers. So shading, you look at the symbol from step 1. Less than. Less than meant that we always shade below our line. My y-intercept was negative 2. Here's negative 2. My slope is down 3 over 1. Down 3 over 1. Now I'm connecting them with a solid line. So here is my ruler. Label mine. So this is line number 1. Now I'm going to shade this one in green. So I'm going to put a green dot right next to number 1 so I know it was the green. I'm supposed to shade below. So where is slope dude? Slope dude always starts on the left part of the line, the furthest left drawn. Slope dude is going to be traveling along my line. I'm supposed to shade below. Anything below slope dude's feet would have been over here on this side of the line. So there's always below slope dude. So now I need to move on to line number 2. So we're going to save this for the second equation. So step number 1. I'm supposed to solve for y. This is the equation they gave to us to begin with. It's already y equals. There's already a y by itself. It's already in slope-intercept form. So step number 1's actually done. Step number 2. What is all the important information that we need so that we know how to actually graph it? So we need to figure out what our y-intercept is, and we need to figure out what our slope is. The y-intercept is a lonely number without any letter. It's 4. Slope is the number in front of x. It's a negative 3. Slope needs to be a fraction, so you need to put it over 1. Now step 3 tells us how do we actually connect these when we go ahead and graph. To figure out how to connect, we look at the symbol that we ended with in step 1. This is the symbol we ended with in step 1. Equal to meant that we are connecting with a solid line. Now step number 4. Step number 4 is how do we shade it? Looking at the symbol left over in step number 1, we're supposed to shade below. Less than is always below. My y-intercept is 4, so here's my y-intercept of 4. I'm supposed to go down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. Now I'm supposed to connect it with a solid line. So here's me connecting with my solid line. You need arrows on both ends, and then I like to label my lines. This is line number 2. Slope dude always starts on the furthest left part of the line. So there's my slope dude. Now I'm going to shade this one in red. So here's my red dot next to number 2, so I know that I am shading it in red. I'm supposed to shade below slope dude's feet. So as slope dude is traveling along his line, where is always below his feet? Below his feet always would have been this direction from line number 2. So the final answer is supposed to be describe the solution. So we're looking for where both red and green are both shaded. I see that only red is shaded right here. The only times we have red and green is below line number 1. So what are the solutions to this system? So I wrote the solutions for the system are the solutions for this one line. Notice anything that was an answer to line number 1, anything that was shaded green is also shaded red. So anything shaded green is going to be an answer to the entire system. This was our green system. So the solutions to the entire problem are the solutions to the one green line. And we're done.
What did we learn today? I can graph and solve systems of linear inequalities into variables. And I look forward to seeing you tomorrow in class.